Hi, George Diamond here. This is the next video in our flipped classroom unit. This is designed for my AP Calculus class. So at this point in the class, I want to do a review on factoring, certain topics in factoring, because we're going to be getting into some problems where our factoring skills are going to have to be pretty good. Now we're going to start off here with our review with some easy stuff here first. We're going to start off with a difference of two squares. So how to factor a difference of squares. Now, difference of squares are special binomials in which the two terms of your binomials are both squared terms. And if you have a difference of two squares, they're going to factor as two conjugate binomials, a plus b times a minus b. So let's start off with the first one, x squared minus 25. Now the x is already squared. 25 is a perfect square. The square root of 25 is 5, right? So our base number here would be x and 5. So to go to factor this will factor as x plus 5 times x minus 5, and that's all there is to factoring a difference of two squares. Just make sure you can recognize that it is a difference, so it has to be subtraction or that won't work. All right, let's try a couple more examples. All right, let's try example number 2. And this is 9x squared minus 100y squared. Now, the two numerical factors here, 9 and 100, those are both perfect squares. The square root of 9 is 3, the square root of 100 is 10, so our base numbers will be 3 and 10. The x is squared and the y is squared, so we have a difference of two squares. So as we factor this one, then this will factor as 3x plus 10y times 3x minus 10y. And there we go. Now, let's try the next one. Now, example number 3 is kind of different. I usually notice that most students, when they get to AP Calculus, have never tried to factor this type of binomial before. So first thing you notice, x minus 2 is not a difference of two squares. But as it turns out, okay, if we have any binomial that's a subtraction, okay, we can make a difference of two squares out of it. Now the only difference is we have to factor within the set of real numbers. We're using radicals, square roots. All right, so to rewrite this as a difference of two squares, okay, let's take the x and we're going to rewrite x as a squared term. Now to make a squared term out of it, we're going to use a square root and squared. Now square root and square are inverse operations. They kind of undo each other. So to make x a squared term, what we're going to do is we're going to take the square root of x and then square it. Now the square and the square root will cancel out, so that's still the same thing as x. So it's still the same term, just we rewritten it now as a squared term. Let's do the same thing with 2. 2 is not a perfect square. So like I said, at first glance, you would not be able to factor this as a difference of two squares. We're going to do the 2 just like we did the x. We're going to make a squared term out of it. Now to do it, we just take the square root of the number, so the square root of 2, we'll put that in parentheses, and then square it. So now we have a difference of two squares where we didn't have before by rewriting it using radicals. Okay, now let's go ahead and factor this as two conjugate binomials. It'll be a square root of x plus the square root of 2 times the square root of x minus the square root of 2. That's how you factor that type of binomial. Okay, now that's something most students have never seen. Let's try another example of that type of factoring. Okay, let's do x minus 9. Now, first thing you notice, x is not a square term, but remember, we can make it a square term. Now, 9 is already a perfect square, so the 9 is good. So if we want to rewrite this, okay, this is the square root of x squared minus. Now, 9 is 3 squared. Right, so you don't have to use a square root on the 9. The 9 is already a perfect square. So only the x. So we have the square root of x squared minus 3 squared. So if we go to factor this now, this will factor the square root of x plus 3. The square root of x minus 3, and that's all there is to factoring that. Okay, let's try our next type of factoring. The next type of factoring is up here. Now, the next type of factoring I want to review with this is how to factor trinomials. Okay, you remember the chart method? Okay, this is what we're looking at here. Now we got 1x squared minus 2x minus 8, a simple trinomial. There's no common factor. Now you always want to check for a common factor. Maybe you can factor that off. There's no common factor here. So this should factor as two binomial factors. Now x squared will factor as x and x. All right? And next, let's do our signs. Now, to get the signs, you have to look at the third term on your trinomial, the last term. Now, the last term on our trinomial is a -8. Now, a minus indicates that the signs have to be different. So 1 plus, 1 minus. Let's go and put our signs in right now. If this had been a +8, the signs would have to be the same, either both plus or both minus. And then the middle term would tell us which. So now let's use the chart method. Let's look at some factors of 8. So you can able factors 1 times 8 and 2 times 4. Now, since this is a difference, we're looking for two of these factors that if you were to subtract them, you would get the middle term. So we would get 2. So technically, we're adding them together. So one of them will be negative and one of them will be positive. And what the middle term tells us here, the -2x, the minus on the 2x tells us the sign of the biggest number. So we're going to use the 2 and the 4 here. And to use the 2 and the 4 would have to be negative and the 2 positive. Because positive 2 plus negative 4 gives us negative 2. So the middle term always tells us the sign of the larger factor. So let's put the 2 here, the 4 here, and we have that one factored now. I just want to do one example here of how to factor a trinomial and sign kind of the FOIL method in reverse. So let's try a couple more. Okay. There we go. Now, let's take a look at factoring a sum of 2 cubes, because we do see these types of binomials sometimes when we're have to factor some problems in AP Calculus. Now, a sum of 2 cubes has to be factored along a particular pattern. Now, a sum of 2 cubes is exactly what the name indicates. It's going to be, these are special binomials in which the 2 terms are both cubed terms. Now, if you have a sum of 2 cubes, they're going to factor as, they'll always factor as a binomial factor times a trinomial factor. And with this particular expansion, you have to remember how the expansion goes, specifically the signs. So you got to watch out. You have a cubed plus b cubed. A and b would be the 2 base terms, if you will. The binomial factor will simply be the sum of the 2 bases. So it'll be a plus b. Now the trinomial factor here, the first term of your trinomial will be your first base squared. So you got to square it. Now to get the middle term, now first of all, if for a sum, the middle term on your trinomial will always be minus, right? And to get the middle term, you have to multiply the 2 bases together. So it'll be minus a times b plus, now the last term of your trinomial is the b base squared, so b squared. So let's look at our pattern. Let's take a look at an example of factoring a sum of 2 cubes. So let's do the x cubed plus 27. Now on the first term, the x is already cubed. So x is going to be our first base. Right? Now the cube root of 27 is 3. So write this as 3 cubed. So my 2 bases here are going to be x and 3. All right, so if we go to factor, let's do the binomial factor first. That'll be x plus 3 times. Right? Okay, now let's do the trinomial. To get the trinomial, remember the first term of your trinomial is the first base squared. Now the first base is x, so x squared minus. So remember the middle term will always be subtraction with a sum of 2 cubes. Now to get the middle term is a times b, so we have to multiply the 2 bases together. X times 3 gives us 3x. There we go. And now let's try the last term, b squared. The second base is 3, so 3 squared gives you 9. And we've got that factorization there. So let's try another one. So let's try another example. Yep. Let's try 8x cubed plus 125. Now let's do our bases. Cube root of 8 is 2, so the first base would be 2x plus. Now the cube root of 125 is 5. Okay, 5 cubed will give us 125. So if we go to factor this now, this will factor is 2x plus 5. Now for the trinomial factor, the first base squared will give us 4x squared minus. Now to get the middle term, you're going to multiply the 2 bases. 5 times 2x is 10x plus, and the last term, 5 squared, is 25. So that's going to be our factorization. So first base squared, the product of the 2 bases, and then the second base squared. Let's do x cubed plus 1. Now, the 2 bases here, first base will be x. This will be x cubed plus 1 cubed. So you can write 1 with any exponent you want. So let's go ahead and factor it. This will be x plus 1 times. Now the first term of your trinomial will be x cubed minus. And to get the middle term, 1 times x is 1x, or just x, plus. Now 1 squared gives us 1. So here we go. Now let's take, a look at the last type of factor. This is a difference of 2 cubes. Now this is factored very similar to a sum of 2 cubes. The only difference is the signs of your expansion. Now, difference of 2 cubes is a special binomial, zero subtraction. Both terms are going to be cubed terms. And when you go to expand these, your binomial factor will be minus, whereas in the other example of the sum of 2 cubes is plus. It'll be a minus the 2 bases. And then the trinomial factor will be a squared plus a times b plus b squared. So the middle term will be addition in the difference of 2 cubes. Let's try some example. Now, the first example here, x cubed minus 64. The first base will be x. Now, the cube of 64 is 4. So our 2 bases are x and 4. So when we go to factor this will be x minus 4 times. Now, the first base squared will be x squared plus, and this will be addition. 4 times x gives us 4x for the middle term. 4 squared gives us 16, and we've got this one factored. Now, another example or two. 8x cubed minus 27. Now the cube root of 8 is 2. So our first base will be 2x. 27, cube root of 27 is 3. So this will be 3 cubed. So if we go to factor this down, this will be 2x minus 3 times. Now square the first base. 2x squared gives us 4x squared plus 3 times 2x gives us 6x for the middle term plus. And then 3 squared gives us 9. So there you go. Now, let's do the last one. This is x cubed minus 1. Now, I'm going to write the 1 as 1 cubed. So as you go to factor this one now, this will factor is x minus 1. So the difference of your 2 bases. Square the x gives us x squared. 1 times x gives us plus 1x. And then 1 squared gives us 1. So plus 1. And this concludes our factoring review. If you have any further questions about factoring, see me after class.